Matthew from Wichita sent me an email asking for a more complicated truth table example. I'll do this, but first I want to review the basic language of truth tables. So if we have proposition A and proposition B, let's do A implies B, A double implies B, which is also if and only if A, then B. And let's do A and B. And let's do A or B. And that should have a point. Let me see how to erase this to get a point.
You flip the pen over for eraser.
Oh, look at this high-tech deal. You can leave that in. That was the voice of Joe Tech, my tech support guy.
There you go.
So A and B are propositions, which mean they can be either true or false. So let's look at all the possibilities. We have true, 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 false, false, true, false, false, and the order does not matter in the slightest, but it's an easy way for me to remember. So here are all the four possibilities, and so this is true, false, true, true, and this is true, true, false, false. The way to conceptualize AND is as a series circuit. So as a series circuit, both switches have to be on in order for the circuit to be on. So this would be true, and everything else is false. And for OR, this is a parallel circuit. So here, as long as one switch is on the on position, which is true, the circuit will have electrons flow. So there's only one way to make an OR false, and that's they're both on the off position or false. And the last thing you need to know before I really start the heart of this video is not. So if we have A and not A, so again there are two possibilities, either A is true or A is false, and the not just interchanges the truth value. So as I said before in that previous video, this is pretty much the logical language that you need to do today's topic, but I wanted this here. So today's topic, as Matthew from Wichita wants, is more complicated truth tables. So I'm going to write that down. More complicated truth tables. So imagine we have the following truth table that was given to us as an example. So suppose we want the truth table for, let's say, suppose we want the truth table for A and B implies not B. How would we get this truth table? Pause the video for a sec and see if you can get all the possible truth values. Okay, so here we've returned. Step one, notice I wrote this a little bit to the right because I wanted to have room for an A and a B. And if you didn't do that, you've just learned something.
Oh, wow.
And now we're going to enumerate all the possibilities as we did before. We have true, 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 false, false, true, and false, false. So this is step one. Step two, we are going to copy down all the truth values exactly as they appear. So notice the A's go true, true, false, false. So we have true, true, false, false. And there are no more A's. The B's go true, false, true, false. So true, false, true, false, true, false, true, false. So notice I've used the actual place that the A's and B's are to create columns, and I've purposely made them to really align relatively well, at least they should. Now the next step I'm going to do in a different color. I think I will pick red. So watch very carefully. The next step, we are going to find all these ands. So again, the way you remember an and is this is a series circuit, so they both have to be on in order for the electrons to flow. So this would be true. But here, this would be false because you have this false here, false, and false. Pause the video for a sec, look at that to make sure that is crystal clear. Then the next step I am going to do in green. So I am going to negate all these truth values for B. So this would be false, true, false, true. So those should be relatively easy. Now the very last step of this truth table is assign the truth values for the implication, also known as if-then. So if we have true implies false, this is false. But if the premise is false, then it doesn't matter what the consequent is. They're all going to be true. So notice, I said that pretty quickly, but notice all these premises are false. So that makes this true. If you don't remember that, you can go back, see when the premise is false, right? The if A then B, the consequent is it doesn't matter, the if A. So that's where that came from. And the question that you might have is, what's the actual answer? How would I write this on a test? And if you want to summarize the answer, the way you do it is you write A, B, and then this whole thing, A and B implies not B. This is how you write the answer. True, 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 false, false, true, false, false. And so what do we have? False, true, 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 false, true. Well, this should be false. Sorry, guys, but I can erase it. False, true, true, true. This is your final answer.